All right, so due to the time constraints, I think we're gonna skip the last presentation and instead encourage all the panelists and the audience to join us in more of a discussion about the entire day. So just I would like to give a quick summary of what we saw today. So at the beginning, we got a great introduction by our principal investigators, Dr. Arnaud Chiluta and Francois Marechal, about the main motivations of CA and MuSES as a project. And what we saw is that basically there is a strong interest and a strong need for coming up with approaches that integrate multiple perspectives from urban design, from building engineering, from process engineering, to better understand how to achieve those low carbon cities. But also there is a need to create tools and tools of analysis that help both growing experts, researchers, but as well as practitioners to use them for real applications during the energy transition. In the second session, then we had a deep dive into the different sub-projects of MuSES. We look at different aspects of occupancy, energy demand. We understand the difference between the current occupancy profiles, and I think Gabriel presented a good idea on how this can be changed in the future by more detailed approaches coming from probability and from different data that is widely available. And hopefully that helps us to have better models to which replicate the future demand of buildings. Also, we have some better intuition about what future low carbon technology can look like in the tropics. Shanshan introduced us to the concept of hybrid cooling technologies and present to us some options on how to analyze it, how to come up with the best technology or some kind of prototypical technology for different districts, and what would be the impact of that with different type of land use mixes. Finding that potentially the land use mix will not change the type of technology, but more the size of technology we use for having an efficient operation. Deng Xiaoming also show us from the lenses of a designer how to basically apply concepts from process engineering and building systems into urban design by the first introduction of energy-driven urban design as a concept on how potentially cities could be planned in the future or districts, which involves the consideration of multiple typologies, multiple archetypes, and then try to find what archetype fits the best when it regards to different objectives, such as reducing emissions or increasing the penetration of PV in areas, self-consumption, etc. And then we introduced the city energy analyst tool as basically as catalyst of the different sub-projects that we had in MuSES, and potentially one of the great outcomes the MuSES project as a whole deliver in this occasion. Later on in the last session, we had very interesting presentations, quite quick, from our researchers and also guests at MuSES, describing another type of layer on the analysis of energy systems at multiple scales. We talk about the interconnection between these grid level power systems and small district heating and cooling systems, and how that could look like in the future. And we talk a little bit about the role of flexibility of the demand and the cost, the impact on the cost and operation of planning the entire infrastructure of a district. We also talk about the effects of climate change on buildings, understanding that they could be quite different, quite diverse. There will be especially a trend to change from heating dominated buildings to cooling dominated buildings, or more specifically, buildings that will need to be dehumidified more than only cooling due to temperature. Then also, Emmanuel introduced us to the new potential studies on the effects of urban warming at the district scale, which aim to basically understand how this big challenge that cities such as Singapore face, that challenge of urban warming, could be mitigated by also studying the strategies in the building and district energy systems domain on how to mitigate the amount of heat that is basically released by buildings and their infrastructure. Later on, lastly, Anastasia introduced us to this aspect of creating guidelines, basically curating a lot of the information that the MuSES project created, using also the tools such as the city energy analyst to basically understand or create heuristics, some principles, if I may say, if I have a little bit of a stretch here, principles on how cities could be designed to have a low carbon production of low production of emissions. And that's it. That concludes pretty much the session. That's a summary. At this point, I would like to basically open the floor for more questions we can have from the attendees and also a discussion from the panelists. While we receive some questions in the last minutes, I'd like to start off with a question, perhaps for PIs, for Arno Schluter, for Francois Maréchal, about what do you think would be the next steps of the MuSES project? What would be the afterlife, and what would be the next things we need to focus on when it relates to research in multi-scale energy systems for low carbon cities?
Yeah, thanks very much, Jimeno, for summarizing that. It's really great to see all the work related to the project in the core and with the satellites in one piece. So I think that was extremely valuable. So of course, it's like with football, after the games, before the game, same with research projects. We are, of course, always trying to go the next step. And with MuSES, we had a great opportunity in terms of context, a great opportunity in terms of size of the project. We were able to have 3 PhDs and postdocs working on this topic. Of course, we're always trying to maintain and ask new questions that are based on the results we identified in the previous cases. And one I already mentioned, the idea is to continue on with a similar scale project in a little bit different setting, but hopefully maintaining Singapore as a location. I believe it's absolutely relevant that we do research in this area and we are based in this area because that helps us to understand the setting and the context. And if we stay on a desk in Zurich, we won't. I think it's absolutely relevant that we have an anchor there and also to use the experiences we had from the previous projects in this kind of setting. But it will most likely be more shared between different locations. So what we're currently looking at is comparing 2 climates and 2 urban environments, one being Zurich in a moderate climate with rather lower densities, and Singapore as a high dense tropical centralized city, and investigating further these interactions of energy supply, energy systems, especially focusing also on renewable energy production and their potential within those 2 urban settings. So that will be one of the next steps. A second step we're currently acquiring, looking for, and this is where Shan is also involved, is the so-called REMAP project. It's a project financed by the Swiss Ministry of Energy that brings together different research institutions that research on technology, district scale technology, and connects basically different labs where there's physical test environments of those district scale technologies, for example, power to gas, storage, different types of energy conversion. And basically this physical environment is connected to a virtual environment, which is a simulation platform that is used basically primarily to control these type of systems and to fuel simulations driven by the results. And the city energy analyst will hopefully become the tool or the environment that will create the virtual cities that drive this physical hardware. So I think the projection will be very interesting, that we basically create the city scenarios this massive hardware is then actually trying to solve. And we're providing use cases, typical use cases in a Swiss context, and that will then deliver answers which hardware is actually most suitable to address those different demands and needs. And vice versa, from the city energy analyst, it gives us a huge opportunity to actually calibrate and further develop the models we have in city energy analyst. And you may have glossed over this very humbly, but since now 7 years, there's a massive development of all those models behind for all the technologies that can be simulated. And of course, some are rather simplified, some are more elaborate, but having physical systems actually there to help us to build those models and to calibrate those models, of course, will enhance the capability of this tool set by quite a bit. So those are two. Then there's a third direction that is also emerging, and that is actually cases. The tool has spread quite a bit, and the models within, and so now we are asked by different environments to actually run case studies, do case studies with different entities with very interesting questions. So most likely we will be involved in a set of case studies trying to actually synthesize the knowledge from those tool sets into strategy and planning decisions. So what would happen if we would do this type of analysis in real planning cases, and how can we generalize? And obviously every planning case is a special and singular thing. How can we learn from these planning cases that is then applicable to other planning cases? So the case study direction has become rather strong, also with other people using CA as a tool set. For us, the challenge is, okay, we don't want to just run a lot of case studies. How can we digest knowledge from the case studies and fuel it back into how we develop these type of tool sets? What type of models are missing? What types of models are most applicable? So it's these three prime directions, and for all three directions, we are in a good state of negotiation. So I'm quite optimistic that we will continue on with these type of studies.
Fantastic. Francois, would you like to connect to that? What's your opinion on the future of MuSES?
To some extent, complement what Arnaud has been saying. So one of the things that we discover now is that by the fact that we have to look at the system integration, we have also the trends to increase or to change the system boundaries. So it means that the city is not only defining needs for heating or cooling, but is going to also ask have an interaction with the mobility needs, the activities also, meaning that we will have also to be to increase the scope of our system vision by looking at the interaction between cities and the rest of the other activities at the level of the national grids, with a trend which I see, which is going towards things that are more decentralized and more circular. So it's as soon as we are going to look at the renewable energy integration, so the harvesting will be at the same place as the use, and therefore instead of having the big infrastructure being responsible for the security of supply, for example, we can have smaller cells that can play the role of the energy management and the security of supply. And this is something that will then be related with another dimension, which is the definition of the sustainability, which is means that we will have also to look at different new metrics that will not only look at the greenhouse gas emissions, but also perhaps the other aspects of sustainability, including social impact. So it means that in the future, we will go towards more, most probably more multi-criteria analysis methods, which will be used to characterize the options that for the system design that will come from tools like the CA, which will be there to generate the options and to show where are the good solutions to be evaluated and compared. This is really the direction that I see.
I think maybe connected to that, to what Francois just said, I think that raises an important question where also to draw the boundaries, right? I mean, obviously, ideally we would take into account as many parameters as possible, but how do we facilitate that, right? Where do we, and also in the presentation we've seen, okay, we need to talk, what are the relevant boundaries for these type of analysis and assessment, right? Where do we connect? Is it going further to the grid, for example, or is it going even the other direction, as you mentioned, considering like life cycle perspectives to be taken into account? So that is, I think, also a question that needs to be explored what are the metrics and what are the boundary conditions for these type of analysis to be helpful.
Yes. But something which is interesting, at least that we can observe, is that on the one hand, you increase the system boundaries, and then you want to try to then go back to a size which is manageable at a place where you can take the decision. And this is exactly what we can see and learn from what we have done. So we have seen also that there are macroscopic simulations that goes into microscopic simulations, and that the results have to be transferred back to the highest level. So I think that managing this data transfer and knowledge transfer between different scales is one of the challenges that we will have in the future.
Mm.
Perhaps in connection to that, perhaps Emmanuel would like to say a few words. I think you presented quite clearly an approach, I think an intention of connecting those multiple scales, and perhaps you can share a little bit already some insights about the challenges of doing such an effort.
Yeah, there are quite some challenges with that. So we work together with the weather research and forecasting team, which is a completely new field for me, and where we have to see where the connection really is, how we can transfer our data, our findings into into their format, into their analysis, and to combine those different scales. And yeah, it has been challenging so far, but it's an ongoing collaboration, and I think good things will come out of it. But yeah, there's definitely limitations which are unforeseen. You expect the different outcomes of that mesoscale simulation, or it's a new field you are tapping into, and there are unforeseen limitations for sure.
Just to connect to that, just quite quickly, I think you mentioned the problem of communication, of course, between multiple expertise. It tends to be basically a big problem in the sense that there is an ontology basically set up between that connects multiple fields at this point. I think we have, our PhDs who come from different domains of expertise and somehow have dealt with the idea of communicating and transferring also data, because data is information, but somehow sometimes it doesn't have the schemas, let's say, basically what each variable means. And sometimes in some domains represent something different, exactly the same data points. And that's something that we see also talking with climatologists, urban designers, and also engineers, as you do in that project, Emmanuel. So I wanted to talk about Xiuming, perhaps, that you have I think from all of us here, you have the eyes of a designer, right? In mind.
Arno.
And also, yeah, Arno, of course. But that idea that you have been on the ground interacting with the other PhDs, I think it's something that doesn't have to be underestimated, that at the end is something that has to be carefully managed. So maybe you would like to share some thoughts about your experience and about the challenges that you find on this.
Yes, there was quite a bit of challenge at the beginning, because I also would define myself that before MuSES, I was also working in an interdisciplinary field, which I was like the architects or the designers were the majority and engineers were the minority. So when I started work with MuSES, it's the opposite. So I would say it was a bit of a long learning process for me. And thanks for everyone having the patience on me that I slowly dive into the energy world. Yes. Well, in the meantime, I'm glad that I also kind of and transmit my knowledge about like urban design, architecture backwards to all of you. Yeah.
Mm-hmm.
It was a
Yeah.
nice learning process.
All right. Yeah, it's definitely very challenging. Now moving on from this type of questions, I'd like to just bring up one question from the audience. And it relates to, I mean, a key problem that many research projects have, and it has to do, okay, with the idea of how do we transfer this to reality, or how do we validate also that the plans we have for the future of our districts actually are successful. So Xiaoyin is asking us, have you worked with city development decision makers, adjust actual implementation planning based on conclusions from CA, and see what you simulated in reality? Maybe Arno, would you like to answer that?
Sure. I mean, this is ongoing. I mean, urban design processes take a long time, so we're trying to jump into different funding processes on different scales. So the connection to planning and city authorities have been established over the past years with a different reception, I have to say. In the Singaporean context, we always had strong interest in these type of analytical tool sets. But also there the question was, okay, how does it fit into the existing environment? In Zurich, for example, it's harder to convince the entities that they should do something like that, at least a year ago. I think this has also changed now from a mindset, and even the legislation of the city of Zurich had made it mandatory that these questions are addressed in urban design patterns. So we're currently involved in a study about new regulations in Zurich, how to build and how to build high buildings and high-rise buildings, and we can tap into this knowledge. With all those sophisticated tool sets, as I raised at the beginning, the question is always who's then the person that operates this, and how will it be integrated into this process? Because now it's great that we can operate it and researchers can operate it, but obviously everyone has a big background of knowledge of doing these type of things, and this is not existing yet. So very often people that are in these positions are a little bit overwhelmed, maybe similar to what Zhongming has indicated at the beginning. And this is also a matter of education. So we need to start educating people outside with these types of thinking, with these types of tool sets and how they can apply them. And this is actually what we're planning to do also as a kind of a side project of MuSES and the city analyst, is to organize teaching and learning for people that are not in research and that basically would potentially be able to integrate this type of knowledge into their planning and design decisions. So I hope very much that in the next stages, and that, for example, two of those projects actually that I talked about at the beginning of the discussion are with the planning entities. So the one is with Zurich entities and Singapore entities, and the other one is with a larger planning entity in Switzerland that takes charge of a lot of buildings. And of course, the case studies actually I was talking about where CA might be used, they're actually driven by people that own larger sections of land that need to be transformed. So one case study, for example, in Bern is a former industrial area that is owned by a single person that wants to convert this into a zero carbon living district. And this person, as well as their architects, they're very interested in learning, okay, how could we actually do that? We have no means to assess that. So we are, I think on all ends, we are trying to get A, this knowledge, and B, those type of tool sets into the hands of people that actually make those decisions. If they will be capable at this point of time, we need to check. Maybe we have to accompany them, or specialists have to accompany them, right? Why don't we think about entities outside of academia that are able to address these type of questions by providing analytics? Or we can set up training courses to empower the people to actually do that. So that's kind of the backdrop of this, but it's not as easy. There's always a demand, and especially we researchers get pressed a lot to do stuff that ends up in reality and does the transfer. And I think that's for a good reason, right? This is all financed by taxpayers' money, so there needs to be some impact in society very well. And I think our research programs address this, but it's not that easy because also practice needs to take things that we develop, right? There needs to be a driver in practice out to actually apply and pick up these type of technologies and methods that we develop. So it only works both ways. But I think during the duration of MuSES in the last 2 or 3 years, the environment has completely changed. I mean, the awareness of climate change, the awareness of urban heat island, just to name two, have massively increased. So I see right now we're in a very good situation of bringing across our message and our tool sets.
And we count with the tools now, perhaps something that we didn't have before. I mean, at the technology readiness level that actually people can dare to take decisions with, right?
Yeah.
That's very, very interesting. We have a hand, somebody raised a hand in the audience. So Ali Hainon, if you can hear us, I'm gonna allow you to talk right now. So please just go ahead and ask us your question. If you're still there, Ali?
Can you hear me?
Yes.
Good afternoon or good morning from Vienna. I'm from Austrian Institute of Technology, and I was listening, very interested to your very interesting lectures and actually talks. One question, I don't want to take a lot of time. We are working in the same field. I'm an energy system analyst, and my question is the challenge is now to address so-called positive energy districts. That is an exercise you are doing. Do you think that you can use or you can cooperate with us by using city energy analyst to address or maybe generate a generic example, or we could provide some data about that? We have our own tools, and we realize that for this challenge of positive energy districts, it is an integrated energy demand supply analysis, but we have to address issues related to flexibilization, to sector coupling, but also to many other aspects related to embodied energy and so on. So it is really a challenge up to the edge of the possibilities by such tools. And it would be very nice if we could, in cooperation with you, if you find it as a good idea, to maybe work on a one generic approach, because that is an emerging research field in the EU level. So there is a plan to have at least 100 positive energy districts up to 2025 here in Europe, and there are a lot of lighthouse projects running now. So that's my question, and we could elaborate further on in certain specific technological but also features from the energy modeling perspective. Thank you.
All right, thank you very much for that, Ali. I think I can give you an answer as still product owner of the CA that's wearing that hat. I mean, in the sense, we welcome any research as well as development projects that entail the reach of reducing the carbon emissions, even up to the positive level, as you mentioned, in future districts. And I think the best way to engage is to first better understand if this could lead to a research project that we can engage in, or also there's the opportunity that you can become a contributor of the city energy analyst, in the sense that you can connect and request perhaps a new feature, develop it on your own. We can give you the aid to make it possible, and hopefully you can analyze the districts that you want to analyze with this type of software, and also hopefully contribute to build this platform even more. That's a quite direct way to do it. For that, we have created a direct channel. I'm gonna put it in the chat, a link that basically explains a recipe of how to come up with a new idea for CA, with a new project idea, and from that, develop it all towards the end into something that can be used for a new research project. So that could be one way of engagement. I think other ways, of course, we are open for collaboration and to hearing ideas research-wise. Perhaps Arno, Francois, you would like to connect to that?
Just from my point of view, it totally makes sense to look for synergies. I mean, one weird thing about research is that everyone invents his own world, which is obvious. Everyone has a driven interest. But I mean, we did CA exactly for this reason, to find synergies and to connect to other people's work. So some work is saved and we can make faster progress. So I think the only thing that will need to be checked in which form could this be is to what level of interaction or integration this would happen, and what is already possible with this type of tool set. So if you talk about positive energy, I assume you mean the entire life cycle and not just the operation of buildings, which then addresses other questions of data towards the archetypes and the materials that are used. We did coupling to mobility, for example, which is then also addressing the aspect of sector coupling, but only on specific areas. So of course, it's also discussing about synergies and technical capabilities. Maybe this is complementary. So it would definitely be interesting following up and seeing, okay, how can this be arranged, and what are potential forms of doing so? You mentioned EU as a context. I mean, there's EU calls coming up where this might be an interesting background.
Yes, perfect. It will be, from our perspective, two levels. First, without mobility and embodied energy, and then second, we think about integrating mobility, because the challenges are different, and also the schemes of defining PEDs are different. So we don't have only one type of PEDs. It is the definition of the geographical boundaries. But first of all, we are focusing on operation energy, and later we could integrate other maybe features like, as you said, mobility and even embodied energy. And might we go further to consider some kind of urban farming within the district scale? But those are a little bit exotic features at the end. It is the frame which is interesting, where you can use such a tool to evaluate all type of really very deep evaluation of the types of end use up to the energy services, and figure out what are the synergies there, how you could, through sector coupling, harness the existing synergies, and what is the existing potentials you can maybe optimizing in terms of local renewables. At the end, it is a building, and I'm not an architect or urban planner, but I have colleagues working in this field. The question is, at the end, we could realize, but for which cost? What is the cost at the end of such district? So from that perspective, it depends from the potential of the considered district, from framework, and from also the potentials of renewables, and certainly also the neighborhood, how we can integrate with the regional electric and district heat energy system. But that's a good start. I think what Jimmy proposed, we will follow up with that, and we will try to connect to you later on.
Very good. Thanks a lot.
Fantastic. Thank you very much.
I wanted to add a very small remark, which is that on the one hand, Arno has highlighted the problematic of first being able to formulate the problem in the right way. And I think that this is also already an outcome of our research. So what is the real problem? So like the zero energy districts or whatever. So defining the right problems. And then afterwards, it's defining how modeling tools can help us. And something which is perhaps also important is that what we can see with the city energy analysis is not only a simulation model. So it's also simulating the decisions of people. So because it is taking choices as if an engineer would have to take the choice. And that's where the optimization is coming into play, by trying to reduce the number of degrees of freedom towards a manageable number that can then be modeled. And that's what the optimization approaches are giving us. And I think that this is also something which will be really important. There will be no need to reduce the scope if we know how to treat the scope. So it means that it will just, this is really something which is behind those calculation capabilities, which are in fact generated in this kind of project.
Should I comment on that? That's I fully agree with you. It is not just the tool; it is the concept. Is it the idea? We have the expertise with that. We are involved in this exercise since almost 2.5 years, so we know that it is a co-creation process. It is not only the engineers, not only the decision maker, but also even the citizen and the energy supplier. And that is the exciting issues in this exercise. It is, in fact, we can formulate that in that way. We are exploring the capability of districts, how far they could get almost positive or maybe be a candidate in the future once the technological performance have advanced, so that we could harness more in terms of local renewables and improve more in sense of energy efficiency at the end use categories. It is a kind of, as you said, an optimization of energy supply and use, and using all existing synergies, again, sector coupling, interaction with the neighborhoods. In the first definition of positive energy district, we are speaking about a positive energy balance on annual scale. So later we could speak also about 7 to 24, which is not realistic for that scheme. So the ideas, the concept, and the expertise is to some extent is existing by also Institute of Technology and our partners also working with us in another project. So we are fully, in line with that, what you have said now, Francis.
Thank you very much for that, Ali. I think that's a great proposal for future collaboration. Would be the best way actually to end up this seminar, and also bring the opportunity for, of course, reach us in the future and see that we can definitely together build a future modeling and also environments like the city energy analyst, but also build at the end better cities. And I think that's the purpose of many of us here. So, I mean, with that said, I thank you very much for the attention. Thank you very much to the panelists. I would like to clap. Somebody here?
Yeah.
Bravo. Thank you very much.
Very good.
Thank you to the attendees also that stick around for perhaps really early hours already for those joining us in Canada or North America of the morning. And also for us here in Singapore, maybe time to sleep. So I would like to thank you all once again for the attention, and hope to see you next time.
Thank you very much, everyone.
There was a question about whether the material will be shared or not.
Yes, definitely. So what we're gonna do now is to go through a small editing process, of course, of the video, and then we're gonna make it available in our website of the Future Cities Laboratory, and also different channels of our researchers. So please be patient. Maybe a couple of weeks will take us to do this, but it will be available, the entire video. All right?
Fantastic.
All right. Thank you very much.
Thanks everyone for preparing. Thanks for listening.
Thank you.
Thanks for listening. Thank you. Bye-bye. Thank you.
Bye-bye.
Thank you.
Bye.
Bye.
Thank you. Bye.
Bye.